Okay, guys. So in the last class, I think we have discussed about. Am I audible first of all? ఒకసారి నాని పిలవరా. Launch. Okay. So in the last class, I think we have discussed about service. Yes. Okay. So today, what we will do is we will try to understand the next most important thing, which is deployment. So we will try to understand conceptually how deployment works, and then we have to understand two more concepts. One is the networking of Kubernetes, like how we have understood the Docker networking, and then the storage. So if you know this, you are all set, and then we can do the deployments, right? So right, let us get started. So all right. Kubernetes deployments. So how does this deployment work? So in Kubernetes deployments specification, we need to describe, okay, first is how many replications of pod do you want? How many replications of pod do you want? And the second thing is information about your pod. So you'll be writing a pod specification over here. And when you write a pod specification, obviously you'll be writing about labels, because in the last class we have understood the importance of labels. If you have labels, you can do load balancing. Even if number of pods increase, then you will have one way of dealing with it, right? Yeah, fine. So along with this, you can also define strategy, your deployment strategy. How are you going to deploy your pods? Okay, so when basically when you're updating a new deployment, how do you want the deployment to be happen? That is your strategy. Okay, so in pod spec, in deployment spec, you have to tell how many replications do you want. You have to tell about your pod. You also have to tell about your strategy. Strategy is an optional. There is a default strategy available over here, right? So why do we need to discuss this much about this? Is because this makes your deployment a zero downtime deployment. So you will be deploying your applications while someone is using your application. So for that, we have to be careful about it. That's the only point. Otherwise, if you are taking a downtime, there is no need for you to speak about all of this, right? Okay. So remember yesterday I've said that there is a replication controller and replica set. Okay. Deployments internally use replica sets. Okay. So the difference between replication controller and replica set is replication controller cannot be persisted. Cannot be persisted. Okay, well, what do you mean? What do I mean by persisted? Stored, remembered. Okay, so let us get started. Replica set can do something with persistence. We'll try to understand what that is. Okay, so okay, So let us go with this in this way. Pod with Docker container. ఒక్కడ కూడా ఇమేజ్ ఇవ్వలేదా? కాపీ పేస్ట్ చేసుకోవడానికి. చచ్చా, I don't want to draw too many things, man. కింద ఉందా? సర్లేండి, ఆ కష్టం ఏదో నేను పడతాను, చేయగలిగింది ఏమో. రైట్, సో ఎక్కడుంది? బట్ జస్ట్ దాన్ని అర్థం కన్నా మనకి ఈ చేసుకోవటం బెటర్. ఓకే, రైట్, ఇట్స్ ఓకే, ఐ డ్రా ఇట్, ఇట్స్ ఓకే, ఫైన్. Terminal icon. Yeah. So you will have kubectl, okay, and generally kubectl as of now is on your okay, I am calling this as master. Okay, so basically what you will do is you will have kubectl, and from kubectl you will be interacting with kubectl, and kubectl interacts with master. When I say it interacts with master, it interacts with API server, because that is the only component which is responsible for communication. Okay, and API server writes the data to the HCD, and after the data is written to the HCD, then either controller manager or scheduler will get into play to do the job. If you are speaking about something new, scheduler comes into play. If it is about maintaining the state, then controller manager will come into play. Okay, and on the nodes, basically you will have deployment. So from kubectl, what you will try to tell us, okay, you will try to tell your desired state. Okay, so I'm calling it as 1 because this is going to be my first deployment. Okay, in this I'll say that I want, okay, 5 Nginx pods with Nginx containers. Am I clear on this? Okay, I want, okay, let me not say 5 pods with my application. Okay, colon 1.0. Colon 1.0, I'm quite sure we understand what it is. That is a tag of your Docker image. So basically what happens over here is we'll have, okay, you have said 5. So okay, and then in this let me take you'll have your application, and let me call it as my app colon 1.0. Yeah, and you said 5. That's the reason what it will do is it will try to create 5 versions of it. 1, 2, 3. ఓకే, పైన 3 చేసేద్దామా? ఈ ఇమేజ్ లో 3 కన్నా ఎక్కువ అయితే కష్టం అవుద్ది. రైట్, లెట్ మీ మేక్ ఇట్ 3 because 3 is visible on this page. There is no other region. Okay, 5 నాకు నచ్చని నంబర్ ఏం కాదు. ఓకే, సో రైట్. సో and generally what we do is we create labels. So since we are creating labels, okay, so let me create labels called as okay, my label is uh, app colon 1. Okay, this is my label. I have a label called as app which has a value called as 1. So I'll apply this. Right, fine. Okay, am I clear with this? So as a deployment, and Kubernetes will do the deployment of it. Now what you want is your developer has given you a new version, and then your new app has came. Okay, so and also one more thing, this is going to be your, okay, so let me call this as my app service. Okay, and over here what you are trying to do is you are trying to have, okay, the same label whatever you had over here. Okay, so we're going to have a label which is called as app. One minute. Man, come on. App colon 1.1. That's it, right? So am I clear on this? Now since I have done this, what will happen? It will create a load balancing. Okay, because I have 3 pods which have this kind of a label, and whoever wants to use my application will use this. Tomorrow, if I want to give this application to the outside, I'll connect this to my external load balancer. Okay, in whatever way it is. So we have done this. Okay, right. So 1 minute. Let me reduce the size of this so that it is simple. So are we clear now? Yeah, right. So this is your deployment. Kubernetes deployment. Okay. So first let me take a screenshot of it. Right. So then what you have done is, okay, your application was running fine, everyone was using your application, all of this was good, but your application will not always stay at version 1, right? There will be a new release that comes to your application, right? So let me save this. One take Kubernetes images cube 11. Okay, so in this scenario, we are deploying 3 pods with your application Docker image, okay, and a service. So cube 11, right? Okay. Now a new version of your application with tag 1.5 is available. Now what has happened? You got a new. Then what we do is in deployment. Okay. Then we make changes to spec as usual. Whenever you want to make anything change, we make your changes to your spec. Okay. And rollout deployment. What is that? Rollout deployment. Okay. Now what is that you have basically happening over here in your version 2? Okay. So you said you got, okay, I want 3 pods with my application colon 1.5. So in this case, now what happens in Kubernetes is you will basically tell this, and Kubernetes will first bring okay. ఇక్కడ వరకు copy paste చేద్దాం. It will bring my app colon 1.5. Okay, and then obviously we'll have a different label. So you will have a label, whatever. You will have a label which is now my app is of version 1.5. So am I clear on this? So it has brought 1. Okay. So once this 1 is up, okay, then what it will do is it will go and remove this one. Am I clear on this? Okay. And then how many you have to bring up and how many you have to remove is a whole strategy. I said that right. In Kubernetes, you can set the strategy. You can say that I want to bring 2 pods and delete the 2 pods basically. It brings the second pod and then it deletes the second one. Okay. It brings the third pod and then it deletes the third pod and then it deletes the third pod which is running. Along with this deployment, it is always recommended that you also change the, okay, you also have some common service, right? Common label. Okay. So what you can basically do is don't have one label, have more than one label. Okay. So you can create one more label over here. Okay. Generally for your application, the better idea is to always not have one tag, but to have 2 tags. Okay. Something like, okay. What shall we write? Okay. Let me write it as app is 1. Okay. And okay. Or let me give okay, I'll write it as IT, whatever that means. IT equals to or project is equals to, let me call it as HRMS. Are you saying this? So we have a tag called as something called as project is equals to HRMS. Try to have one pod or one label in common to everything which you create. Okay. So don't try to create with only one label, because one label means your service will not, you have to change the service. Till that service is available, then you will have a problem. Okay. Now, before I am doing the deployment, what will I do is I'll erase this app colon 1.1. Bring me all the pods with PR equal to HRMS. Then I'll be getting the links of my old pods and links of my new pods. So once my new pods are up, then I'll bring app equals to not 1 now. It is going to be 1.5. So let me write it over here. App is equals to 1.5. Are you clear with the whole story now? Yeah. Now I got this. Now I got this. So basically, what is happening now? It is bringing one pod. It is deleting one. So if it is 1 or 100, that is something which you need to set. Okay, the strategy in which you tell is, okay, I want all the older pods to be deleted in which order? How many you want to delete them at one shot? But remember, by default, it will bring the new one. Only when it is working, it will delete the older one. If the new one is not working, it will not basically delete the older one. So did we got our version 2? Yes. Okay. So this is called as rolling out deployments. What is this called as? Okay. So roll out. That's yours. Then it will bring only 2. After the second pod is created, then it will remove all the older ones. Yeah. Okay. Number is I'm just giving this number because it is easier to understand. That is your strategy, right? So whether you want to, how many you want to delete at one shot, how many you want to create at one shot, that can always be changed. Am I clear on this? So what is that we have done now? We have rolled out a new deployment. Okay, this service is not part of the deployment, but you have to ensure that you are changing service accordingly, because your users will be accessing your pods not directly but via service. So ensuring your service is connected to the deployment is your responsibility. Okay, right. Now, this is the story. Yes. Okay, fine. Now let me change it. Let me call it as cube 12. Okay, right. Review. Okay. So now, for some application issue, for some reason, your new version rolled out as defective. It is not right. Okay. So what is it you want to do now? The new version is not working. So you have to bring back the older version. So ideally that means that creating a new server, installing the older versions again. Okay. But Kubernetes deployments support undo rollout or going back to previous deployments. Okay, versions. So remember, we have said 1 and now I have added something called as 2. Here 1 means my first version of the deployment and 2 means the second version of the deployment. If second one is not working correctly, what I can do is, okay, this is not working correctly for my case. So I want to undo. Okay. If I undo, basically what happens is, okay, it will start, okay, removing whatever it has created. Okay. Okay, don't worry about the extra tag which I have written. But if you see, it has slowly removed. But remember, it will not bring the same containers back. It will bring a new pod with the same image. ఇంతకు ముందు చచ్చిపోయి మళ్ళీ తిరిగి బతికేస్తాయా నీది మమ్మీ సినిమా కాదు, right? Whatever was dead before, will it recreate that? Will they be born again? No. It will be a new pod with the same image running in there. It will be a new pod with the same image running in there. So now, okay, take me back to version 1. This is called as undo rollout or rollback. Okay. Or go back. And remember, you are doing all of this where application is running, not by stopping and taking a downtime of application. Your application is running, you are basically executing this, and all it takes is 2 or 3 commands. All it takes is 2 or 3 commands. Am I clear on this? Yeah. So am I able to switch between my versions of deployment? Yeah. So in Kubernetes, basically in deployments, what happen? It will create the deployment. It will ensure your application is running. But if that is not working by any chance, you can go back to any versions. Here I have only 2 versions, 1 and 2. But let us assume that you have 100. You can go to 50. You can go to 41. Right? So you can go back to any older version where your application was working in a stable mode. Clear on this? Okay. So this is the whole concept of deployment. So this is inbuilt feature of Kubernetes. Unlike many other tools where you have to design it, in Kubernetes, deployment is a inbuilt feature, right? So now so if you roll back to version 1, okay, the scenario looks like below. Am I clear on this? Yeah. So can I roll out and roll back deployments? Okay. And for that, your previous history has to be saved. Yes or no? Your previous history has to be saved. That is what replica set can do in addition to what replication controller does. Replication controller, okay, cannot persist the state. Replica set can persist the state. And whenever you create a replica set, basically what happens is internally an extra label is also created. Internally, an extra label also gets created. Basically, that is how this whole concept of deployment works. Am I clear on this? Right? So, are we clear about the major controllers now? Yeah. So, but in reality, you'll be using deployment plus service. That is going to be your template. Deployment plus service. We know that we learn about pod, but we'll never be writing pod.yaml. We'll always be writing deployment.yaml and service.yaml. Right? In many cases, we write all of that in the same file. Okay. The reason is at the end of the day, I want my application to be running all the time. Okay. Clear on this? Okay. So now look back from controllers. We started with pods. We said that a pod can run containers, can run more than one container. And after that, I said that pod, if you want your pods to be always in some state, then you have to use something called as replication controller. And then we have said that there is something called as daemon set. Okay. And then we have said that there is something called as replica set also. All right. So, and after that, now I'm speaking about a controller, which is deployment. Okay. In reality, in most of your projects, you end up creating deployments. But to write this deployment spec, we need to go through the whole YAML cycle, which we basically have started a few days ago. But are we clear on this conceptually? Right? So what is this Kubernetes deployment all about? Okay. It is all about deploying a new version. How do you know that it is a new version? Because with every version, generally remember that the general phenomenon is your images tag changes. Your images tag changes. That's how we come to know about a new version, right? Developer writes a code. Whenever developer writes a code, you build the code. Once you build the code, you will build a Docker package. Whenever you build a Docker package of a new version, you will create a new tag. New tag you will upload to the Docker hub, the Docker push command, right? So once you have that, now you have to deploy that onto your Kubernetes. That means that you have to have a Kubernetes deployment specification. Kubernetes deployment specification. Am I clear on this? Yeah. Okay. And it is never a recommended practice to use my_latest, my_1.0, my_1.5, my_2.0, because latest number might not be the same even after 2 years, right? So always use your Docker labels with some Docker tags with some version number, never a latest one. Latest one is good for practice, not in reality. Clear on this? Yes? Good. So Kubernetes deployment plus service. Okay. In interview, they might ask you about 1,000 things, but this is how we create a deployment of any application. This is how we create a deployment of any application. Clear on this? Right? So, but here I have written only one, my application has one Docker container or one pod, but your application might have multiple microservices. Right? And you will have a deployment file for every microservice. You will have a deployment file for every microservice. For example, your application is broken down into 10 services. So then literally as a DevOps engineer, you will have 10 deployment files and then 10 service files, 10 deployments and 10 service files. Am I clear on this? Yeah. So conceptually, do we understand about Kubernetes now? Yeah. So now you think of why did we come back? Is there any reason for us to use Kubernetes now? Right? Rather than using Docker containers individually, right? Because in Docker, we don't get all of this. In Docker, we don't speak about basically scaling up, scaling down, right? Doing a deployment not working, coming down, right? And then we have some kind of a load balancer, which is a service. And then I've also spoken about Ingress. Ingress is a HTTP based, HTTP layer 7 or a layer 7 load balancer, which also knows about your URLs. We don't have this much of intelligence when we are running basically in one machine with Docker installed on it. We cannot do all of this, right? That's where your Kubernetes comes into play. Kubernetes is all about deploying at scale, right? So you can use the same kubectl commands, whether you are using it on AWS, whether you are using it on Azure, whether you are using it on your company's VMware, or whether you are using it from your laptop. The commands are same. The purpose why we use Kubernetes is same. Clear on this? All right. So do we understand all of this now? Yeah. Okay. Good. All right. Any questions on whatever we have discussed so far? Okay, right. How does a database undo work? We need a database admin's help or DevOps work. Okay. So I have said this earlier also. Where does your database store the data? In some hard disk file. Okay. So if you want to preserve that, what is that you will have? Volume. If I undo the database and if I use the same volume, will I not get the same data back? Yes. So then why do you need database engineer? Clear on that? Yeah. So my database lo marindalla ekkada untadi topmost layer of Docker, and to preserve that we use something called as volumes. Now if I am going to the newer version or going back to the older version, if I am able to use the same volume, will I lose any data? No. That's the whole answer, right? Okay. So I am seeing a lot of companies still using Docker than Kubernetes. Any reason for that? They start with Docker, sir. That is the starting point. Okay, right? So then once you have Dockers, you're basically creating containers and all of them. Then for deploying, your company cannot go to production with one server running Docker. No. Okay, if they are using Docker, they might be using Docker Swarm, not really Kubernetes. Okay, Docker ఒకటి ఇన్స్టాల్ చేసి నా ల్యాప్టాప్ లో ఇన్స్టాల్ చేసినట్టు చేసి నేను ప్రొడక్షన్ కి వెళ్తా అంటే పని అవ్వదు తేమలు, because you will not get any of these orchestration features. If you are using Docker, they have to basically use at least Swarm version of it. So when was Docker Kubernetes introduced? So why don't you see a Wikipedia page of Kubernetes? I don't remember dates, man. I'm not good at that. Dates, versions, I am very bad. Okay. So, right. What is the rollback of deployment? So remember, we have gone to the version 2 and then we said that version 2 was not working and we wanted to come back to the version 1. That is rollback. Okay. You have given a new version. మీరు తప్పు తెలుసుకున్నారు, పశ్చాత్తాపడుతున్నారు, ఇప్పుడు వెనక్కి వచ్చేసే అవకాశం ఉంది, రైట్? So you can come back to your older version. That's what a rollback is. Difference between replica set and replication controller. Replica set can be persisted. Okay, so which means that Kubernetes internally uses replica set because replica set can be stored in the etcd. Okay, not only desired state and actual state, it can store some extra information about your replica set. But when it comes to the replication controller, it stores only what is actual state and what is desired state. Right? That's what it is. Is there any command to roll back to the previous replica set? We cannot do that directly. Deployment does it internally. Yeah. Okay. Deployment knows how to use replica set. If you are having multiple applications, how do we manage? Even if you have multiple applications, in the case of Docker, you do deploy one service at a time. You will not do the whole deployment in one shot. So for example, I have made changes in my login service. So I'll be doing the deployment of login service, not all the services. Okay. So you are not impacting the whole application. You are impacting only the part of your application. That's how microservices are. That's how your Kubernetes works, right? So if you have multiple applications, let it be. But how many deployment files do you have? You do one deployment at a time. Okay. అప్లికేషన్ మొత్తాన్ని మార్చారు. మనం ఇప్పుడు ఒక రోజు సెలవు పెట్టంగానే రూమ్ కి పెయింట్ వేసేసినట్టు, రైట్? సో అలా కుదరదు. It is done in smaller portions. That's how here what we do is we don't do large scale deployments. We will not say that okay, I'll be doing the whole application deployment at one shot. That is not how Kubernetes works. In Kubernetes, what we do is rather than doing a whole deployment at one shot, we do smaller deployments many times. Yeah, that's the whole. Not only in Kubernetes, in many companies, that is the basic story now. They are not giving a very big releases; they are giving multiple smaller releases. Like how you get your updates on your Android. Okay, so it is not a major update, but every day or once in a week you will get some updates to your Android system and then you upgrade, right? That is the basic story around it, right? Okay. What is load balancers? Where is load balancers? Will come in Kubernetes. If they are on their way. Inka Ola cab దొరకలేదంట వాళ్ళకి వస్తాయి. ఓకే, నిన్న క్లాస్ మీరు వినుంటే మొన్నటిది, I have said that services do the job of. Yes. Right. Okay. In rollback deployment, I get my pods back, but we are deploying applications in containers, so our containers will not undo. What is the use of undo the pods? See, if you say that I want to run the previous version, is it not running the previous version of previous tag of Docker container? Yes. Your application was my app colon 1.0. If I am running a container with my app colon 1.0, is it not your previous version of your application? So then what is the relevance of a doubt which you're asking? Pod is nothing but pod can run a container, right? And in the pod, you basically tell what is the version of the image which you are trying to, or a tag of an image which you are trying to work. If you are trying to tell that I want to undo my deployment back, basically what is that you are trying to do? You are trying to basically get the same state back. Okay. How do you get the same state? By running the pod with the same container, right? Rather than you manually doing all of this, Kubernetes gives you an option of rollback and rollout deployments. That's a basic scenario. Yeah. Okay. Can we have two app version labels in one? You can have thousands of labels in your service because labels are not logical stuff. Okay. Meeku nachina label cheskondi. The only purpose of label is to load balance. Okay. Tomorrow let us assume that you have app colon 1 and app colon 2 label also. But over here what you give matters, because those pods will be load balanced. Those pods will be load balanced. Okay. Right. Can you please explain this figure? That is what I have been trying to do for the whole day. Okay. Video is lagging or delayed. Okay, I don't see a problem with the internet, but I am quite sure that it has something to do with this stuff. Okay. So in undo rollout or rollback model, can the application running on pod on two machines, if application deployment was not successful, then can roll? See, still application deployment is not successful, it will not say that your application has been. For example, you had 3 servers and one server is dead for some reason while you are doing a deployment, then your deployment itself will not be succeeded. So probably you might be stuck in a state where you have one new container, one new pod, and older version of the pod removed, but you have 2 more to go, but you are unable to create them. So your deployment was not successful. Till you add that new node coming in, it will not be successful. Okay. Yes, because your new pod state was I want, what is that? 3 pods running with my app colon 1.5. If you have only 3 apps running with my app colon 1.5, then only your deployment is successful. In that, if there is any failure, the failure can be due to your pod, due to your container, or due to the nodes, then your deployment is not complete. Your deployment is not complete. So you can stop that at any moment. That's the whole point. Right? Okay. Okay. As a part of what is it? Oh boy. For newer version of the pod which created, one will be deleted. At this instance, remaining pods will be older one. See, how can you tell the app is not the same? Let us assume. Let me give a very simple example. You are running Amazon shopping site. a new version of Amazon shopping site has came. Okay, or deployed in Kubernetes containers. Okay, where is this application's whole data stored? Somewhere in a database. You are not touching the database. Okay, now you are touching the UI layer or whatever middleware layer of it. Okay, I've done that, and some issue came. Okay, that could be an application error or application crash, whatever it is. And now what you have done is you have done the rollback of the application. Right? So your application's whole data is in the database and that has not changed. Yes or no? Okay. So this was not working. This was crashing. So you got back to the older version or older deployment. Will it not correct? Yes. That is one case. Let us assume that your application has volume. Your application has volume. So when you roll back, will you not get the same volume back with the same data back? So is it not your older version? Okay. So if your application is designed in a way that it stores all of the data in a database or at one place which is preserved as a volume, rollout works it, and undo rollout also works, right? Or rollback will work. But if your application is not designed in a way, edo data right, then it will mess up. Depends on how your application is basically run. Okay. So it is the same. Okay. Right. If it is not the same, then what is the purpose of having my app colon 1.5? That's my whole question. First of all, your Docker file itself is wrong. నేను డాకర్ రన్ కంటైనర్ రన్ మై యాప్ కోలన్ 1.5 అన్నప్పుడు కొత్త వర్షన్ 1.0 అన్నప్పుడు పాత వర్షన్ కి వెళ్ళలేనప్పుడు అలాంటి డాకర్ ఫైల్ ఎందుకు నాలుగు తీసుకోదు? Yes or no? So in that, if I have to preserve any states, will I write volumes? Yes. So if I have done all of that, Kubernetes manages that. Right? So if this is not working, that means you have messed up with your Docker file. So first go and fix it. Right? I am from testing background. Can you explain what is deployment? How do we? Okay. So how many people are from testing here? All right. So every day morning you go and test a new version of your application. Yes or no? That is what happens in agile testing at least. Yes? Avuna? Avuna? All right. So how will you get the new version every day? Who is doing that? In the case of Kubernetes, deployment does it. So how your application is deployed, that is a secondary story. Let it be jar, var, or whatever nonsense it is. Right? Every application has a different way of deploying. So if it is Java applications, you'll have var or jar files. Right? If it is .NET, we might have some DLL files. If it is Python, I might have some pip packages. I am not worried about the deployment steps. So every day you need to get a new version to release. And whenever you want to get a new version, there are certain steps that have to be done. Okay. So in the case of Docker, all of that are handled with a Docker file and your Docker instructions. If your Docker instructions are correct, I'll get a new version every day. And that is what your Kubernetes is taking and deploying. Okay. So you need not worry about what is jar and what is var file. But if you still want to understand what is jar and what a var is, var means web archive. It can run generally on any application server like Tomcat, JBoss, WebLogic, or whatever it is. Jar is basically a library. It cannot run on its own. But in some cases, we have two kinds of jars. One is a jar which is a library, and jar which is self-executable. Right? Self-executable means if you say Java-jar and give that jar's value, it will run on its own. Okay. So that generally your these days your Java technology is using something called as Spring Boot. And when you use Spring Boot, what you get is self-executable jar files. And that's where when you say Java-jar spring.jar, it is working because it is a Spring Boot service. It has a simple server within it. Any Java application, web application requires an application server. Something like Tomcat, JBoss, Jetty, WebLogic, WebSphere to work. Okay. So whenever you are saying Java-jar, spring.war, what happens is in spring.jar there is a small application server which is called as Jetty. And your application is executing underneath it. Right. Okay. Fine. Any other questions in the classroom? Okay. Now, conceptually, we know all of this, right? Okay. So over this weekend, what we will do is we will try to write spec for everything, whatever we have done. So before coming into the next class, I will not clarify what a Docker service, what a Kubernetes service is, what a Kubernetes deployment is. I will be writing specifications. So please ensure you go through all of this and come with an understanding of every topic which I have spoken about, because I have not spoken about anything technical. I have spoken about with images. So how this concept is working. So we are getting into technicality of this in this weekend. in this weekend, right? So go through everything. Okay. So the first topic which I am going to start tomorrow is what is Kubernetes networking and how does it work? We have understood Docker networking. We have said that there is something called as virtual Ethernet. There is something called as a bridge. All right. So we'll get into Docker networking. And remember, while installing Kubernetes, we have installed something called as VNet. Right? There was something called as Flannel, Calico, and all of that stuff. So what are they? Okay. And then in Docker, we have discussed something called as volumes. So Kubernetes has to handle that volumes, right? So what is that is present in Kubernetes to handle Docker volumes? That will be our next discussion. Then we will write a specification for this application or one application, and then we will try to do the whole stuff. So we'll be writing a pod spec, we'll be writing a replication control spec, we'll be writing a deployment spec, we'll be writing a service spec, and all of that specs. Okay, we write it and let us do the deployments of that. Okay, once we understand in Amazon EKS and Azure AKS. Right? What is Amazon EKS and Azure AKS? Amazon EKS is a Kubernetes as a service provided by Amazon. Whenever someone is saying Kubernetes as a service, that means that you need not manage master nodes. Master will be managed by them. Okay, the only thing which you have to worry about is nodes. Okay, clear on that? The same thing we'll do with the AKS. Even Google Kubernetes engine, same story. Kubernetes as a service ante master daridram mana pattichukone avasaram ledhu. Right? So you will be directly told how to install kubectl and you can get going. That's how Kubernetes as a service works, right? So we have our own version of Kubernetes, right? We'll be having one Amazon's version of Kubernetes, which is Amazon's EKS, and then we'll take one Azure's version of Kubernetes, and then we will be trying to do all of this on all of them, right? So we'll be working on all the three. So in this weekend, I want you guys, all of you guys, to come with the classroom with an understanding of this, because it is going to be completely hands-on. I'll be typing something, right? So if you understood all of this concept, if you have gone through them, it will be a wonderful ride. Otherwise, లేదంటే కొంచెం వెనక్కి పరుపులు గట్ట పురమాయిస్తాను, అక్కడే పడుకోండి. ఏసీలు కూడా ఉన్నాయి కదా, కొత్త పెయింట్ కూడా బాగా నిద్రట్టుంది. Alright? So come to the next class with an understanding of what has happened, right? Otherwise, the next 6 hours will be troublesome, right? శనివారం ఆదివారం నాకు పనులు ఉంటాయండి, మాకు ఇంట్లో చాలా పనులు ఉన్నాయి, ఇంట్లో అందరూ తిడుతున్నారు, ఇవన్నీ కోర్స్ జాయిన్ అయ్యే ముందు ఆలోచించుకోవాలి. నేను డెమో రోజే చెప్పాను, ఆల్మోస్ట్ రోజు క్లాస్ ఉంటుంది. యా, so every day you'll have a class is what I promised in a demo. So don't tell me that I am on travel and all of that stuff. Yeah, if you are on travel, try to have an alternative plan. Yes, ఇంటికి వచ్చే పాలోడికి ఊరెళ్ళే ముందు చెప్తారా, నేను ఊరు వెళ్తున్నాను, 2 రోజులు పాల ప్యాకెట్లు వేయొద్దని. రైట్? క్లాస్కి మాత్రం ఆల్టర్నేటివ్ ప్లాన్ ఉండదు. ఓకే, మీరు క్లాస్కి రాకపోవడం నా తప్పు. ఓకే, don't think in that way, because there is a lot of stuff. Once we finish all of this, next week we have to understand OpenShift. Okay, so what OpenShift is all about is we are doing all of this work in Kubernetes, right? Okay, Docker work, whatever we are trying to do, Kubernetes is trying to do for us. Whatever work Kubernetes is trying to do, that can be simplified with OpenShift. So that's the whole point. So it is all simplification. But OpenShift is not a free product, so we'll understand it. And there is something called as Helm. Okay, Helm charts and so all of this. See, there is loads and loads of relations, loads and loads of concepts that are coming. And last weekend, Microsoft has come up with something called as Rudder and open application model. For Kubernetes, they are creating one more open models. So if that comes into play, how stable Helm will be, I'm not sure, because open application model tries to tell that. Okay, so whenever you are writing your application, there is no need for you to worry about this Kubernetes specifications. Define your application in some way that then I'll be able to do the deployments for you. You have to learn all of that. And world is changing very fast. And don't tell me that, okay, I didn't understood network and all of that stuff. My network and right? So you have to spend time. There is a lot, and this is the most. So you learn about artificial intelligence, right? Every day something new happens in the industry and all of that stuff. In the case of DevOps, Docker is that area. Docker and container is an area where every day some innovation, someone tries something, okay, and something might become popular. So things are changing very fast. So for example, there is one feature in Kubernetes which is coming, which is still in alpha stage. That's why I have not spoken. There is something called as ephemeral containers. In the pod, we can run something called as ephemeral containers. Ephemeral containers is which remember about themselves. Okay. So if that comes into play, what will be the impact of volumes, persistent volumes, whatever we are going to learn? There is loads and loads of stuff happening. Okay. So whatever I've spoken till now is sheer basics, and we need to have an understanding of that. And you should have one Kubernetes installation to practice it. Clear on this? Yeah. So I'll be creating an EKS and AKS also. If you are having an AWS account, create an EKS. If you are having an Azure account, create an AKS. Okay. And anyway, I have one kubeadmin also, right? I'll be using kubeadmin, I'll be using EKS, and I'll be using AKS in my next classes. So before getting into any other stuff, let me get into the discussion of, let me get into the class timings. Okay. So ఈ క్లాస్ టైములు జాగ్రత్తగా వినండి, ప్రత్యేకించి రికార్డింగ్లు వినేవాళ్ళు. Please be very careful about this class timings, especially the people who just don't come to classes and listen to recordings itself. నేను మీ గురించే మాట్లాడుతున్నా, రైట్? ఓకే, ఫైన్. సో టుమారో 7 to 10 AM Kubernetes. Sunday 7 to 10 AM Kubernetes, right? Sunday 6 to 7:30 AM. Okay. Oh, sorry, PM. We'll have Azure. We are discussing on ARM, right? Yeah. 7:30 to 9 PM. We'll be having an AWS class. Okay. Sunday in the evening, if Kubernetes is done, okay, we'll have foundation class. Otherwise, we'll have a Kubernetes class. So you will get a foundation class link Sunday in the morning. Okay. So if 6 hours is not sufficient, we'll take 1 more 3 hours for Kubernetes. 9 గంటల పని నేను క్లాస్ లో చేసిన పని మీరు ప్రాక్టీస్ చేయాలంటే మీరు ఎంతసేపు చేయాలో ఆలోచించుకోండి. Yeah. And I'm trying to tell that this is all required. Okay. And if you have understood this concept, it hardly the class takes 3 hours for me to finish all of this, because EKS and AKS setup is all about running 2 simple commands. Okay, and just waiting for it. It is time taking. So if I run that command and parallelly if I write specs, it takes 3 hours for me. But since you guys also want to do it, what I would recommend is you can bring your systems and don't complain about network. Network ఒకవేళ బాగా పని చేయబోతే మీ జియోనో ఎయిర్టెల్ వాడుకోండి, రైట్? ఫస్ట్ థింగ్ ఏంటంటే our routers will have some kind of what you call congestion. They cannot serve more than certain number of traffic, right? మన క్లాస్ లో ప్రాక్టీస్ చేసుకునే వాళ్ళు వాళ్ళ మొబైల్ కూడా కనెక్ట్ అవుతున్నారు, దాంట్లో జబర్దస్త్ చూస్తున్నారు, రైట్? అండ్ ల్యాప్టాప్ లో ఏమో కుబర్నెటస్ చేస్తున్నారు, రైట్? ఇలా రెండు వాడేవాళ్ళు దయచేసి ఇలా ప్రాక్టీస్ చేసేటప్పుడు ఆ వైఫై కట్టండి. మామూలు టైంలో చూడండి, మీ ఇష్టం, అది మీ కెరియర్, ఐఎమ్ నాట్ ఇంట్రెస్టెడ్. బట్ వెన్ లాట్ ఆఫ్ పీపుల్ ఆర్ డూయింగ్ ఇట్ ఇన్ ద క్లాస్ రూమ్, you can basically, and one more thing, I'll not stop you for doing. I'll continue whatever I'm doing. If you have practiced it correctly, you can write a specification. And while writing a specification, I will not write it. We will always go back to that API reference. Remember how we have written the pod spec? We have gone there, we have read that, and we'll be filling a YAML file. That is what I'll be doing in the classroom, and that is what it is going to be. So Sunday evening, whether it is a foundation class or whether it is a Kubernetes class, will depend on how much we finish on that, right? Okay. And one more thing, Monday will not have a class. Okay. From Tuesday we'll start site reliability engineering. From Tuesday we'll start site reliability engineering. Okay. So we'll have one open shift. Okay. But before we get into open shift, I'll give you an exercise. Okay. As usual, I said that, right? Some of the people have sent me a practice of Terraform also. So 4 exercises, whoever finishes it, okay, I'll be taking a special class for you guys. Okay. So that's the reason. So today you have a second exercise that is coming up. Okay. Or on the Sunday, I'll try to give it. You can submit it till next Saturday. Okay. So, and then we'll discuss about OpenShift and Kubernetes Helm. Okay, that's the whole story. You work, I will tell more. You don't work, whatever I'm trying to tell is more than what anyone tells in Amirpet. So you're already ahead of competition. మీరు అమీర్పేట వరకే బతుకుదాం అనుకుంటే వీఆర్ ఆల్రెడీ అహెడ్ ఆఫ్ అమీర్పేట్. ఓకే, నేను అంటున్నాను కాదు, గో అండ్ కంపేర్ ఇట్ దిస్ కుబర్నెటస్ కంటెంట్ విత్ ఎనీథింగ్ దట్ హ్యాపెన్స్ ఇన్ హైదరాబాద్. యూఆర్ ఆల్రెడీ అహెడ్ ఆఫ్ కాంపిటీషన్. మీరు హైదరాబాద్ వరకే ఆలోచిస్తున్నారు అనుకోండి, నేను హైదరాబాద్ వరకే చెప్తాను. రైట్. సో ఇఫ్ యూ వాంట్ టు లెర్న్ ఓపెన్ షిఫ్ట్, Helm, or all the other advanced things that comes into play, show me that you are worth it. ఓకే, అలా చేసిన వాళ్ళకి నేను ఏమన్నా చెప్తాను, అవసరం అయితే నాతో పాటు నా ఆఫీస్ తీసుకెళ్తాను. రైట్. ఐ డోంట్ మైండ్ గివింగ్ ఇన్ఫర్మేషన్ టు ద పీపుల్ హూ వర్క్. ఓకే, so that's the reason when you ask me a question, my answer will always be a question. It will not be answer straightforward until unless it is something which I can answer straight away. Right. So I ask you with a question because I want you to think. Because tomorrow Kubernetes might add few things more. All right. So, and everything will not be trained. You cannot be trained with everything. That's where we learn the concept. Clear on this? Yeah. Okay. Fine. So this is going to be our timing. And Sunday in the evening, you might have a foundation class or you might have a Kubernetes class. It depends on what has happened on those 2 days. Clear on that? Okay, guys. So I'll stop it at that. And if there are any unanswered questions, I'm sorry, please make a class in the weekend for 2 days because we will practice. I think that is what I've done, right? Abhishek, I'm following it as per you. Okay. How to pass parameters to Docker containers. Go to our class when I started speaking about environmental variables. Yeah. In Docker, we have spoken about environmental variables, right? After Docker service, can you teach Helm chat? No, screw me, you are worth learning Helm chat. ఓకే, నేను ఇప్పటి వరకు చెప్పిందే ఎక్కువ. మీకు ఇంకా కావాలనుకుంటే, లేదు నేను నేర్చుకోవడానికి నాకు లక్షణాలు ఉన్నాయని మీరు నాకు చూపించండి, అప్పుడు ఖచ్చితంగా చెప్తాను. అవసరం అయితే Kubernetes అప్లికేషన్ డెవలప్మెంట్ అని ఇంకో ఏరియా ఉంది, వేర్ యూ కెన్ రైట్ JSON కోడ్ అండ్ దెన్ స్టార్ట్ రన్నింగ్ Kubernetes. ఐ డోంట్ మైండ్ స్పీకింగ్ అబౌట్ దట్ ఆల్సో. ఓకే, బట్ ఇదే చేయని వాళ్ళకి అది ఎందుకు, అది నా వర్షన్. లేదు మేము ఇది చేసామని మీరు చెప్పండి, చెప్తాను ఖచ్చితంగా. ఓకే, సో ఐఎమ్ క్లియర్ ఆన్ దిస్. వాట్ ఎవర్ వీ హ్యావ్ లెర్న్డ్, వీఆర్ ఆల్రెడీ హెడ్ ఆఫ్ కాంపిటీషన్. మన కాంపిటీషన్ కన్నా ముందు ఉన్నాం. లేదు నేను నాకు Kubernetes మీద ప్రేమ ఉంది, ఇంకా నేర్చుకోవాలంటే ఆ ప్రేమను నిరూపించండి అని నేను అడుగుతున్నాను. ఓకే, రోజు క్లాసుకి వస్తా కాదు ఏదో చేసి, రోజు క్లాసుకి పొద్దున్నే నూనె రాసుకుని తల దూకు పక్కకి దూకొని వస్తే అది ప్రేమ కాదు. దాన్ని నాకు తెలిసి ఇది అంటారు అనుకుంటా, ఏంటి డిసిప్లిన్ ఏమంటారు తెలుగులో, క్రమశిక్షణ. యా. సో క్రమశిక్షణ డాకర్ మీద ప్రేమని Kubernetes మీద ప్రేమ ఒకటే కాదు. రైట్. ఐ కేమ్ టు ఎవ్రీ క్లాస్ ఆఫ్ ఇయర్స్. గుడ్ గుడ్. రైట్. డాకర్ అర్థమైనా అర్థమైపోయినా రోజు పొద్దున్నే లేచి అలవాటు అన్న అవుతుంది దానివల్ల. ఇప్పుడు మనం ఆలోచించాల్సిన దాని గురించి కాదు కదా, డాకర్ గురించి. రైట్. ఎస్. ఓకే, సో డూ దిస్. ఓకే, ఐ డోంట్ మైండ్ స్పీకింగ్ అబౌట్. క్యాన్ యూ ప్లీజ్ కవర్ canary dip? I'll cover everything. I'll cover myself. Right. But first prove me. I'll tell whatever I know about Kubernetes. Right. So before you happen, maybe we start OpenShift from Tuesday. No, sir. Okay. Here schedule works according to me, right? Okay. Yes. Okay. మీరు నేర్చుకోవాలి దాని మీద. మీరు see, the reason why I do OpenShift on that, see, just think in that way. Sunday evening 6 to 9 I can put OpenShift I want. I'm quite sure that you'll be able to finish Kubernetes in the next 6 hours. Why am I not doing that? In that case, you are just listening to OpenShift. That will not help. For that, Red Hat has a wonderful, they had conducted one session where they have introduced OpenShift. What is OpenShift? Why should you use OpenShift? ఆ యూట్యూబ్ వీడియో చూస్తే సరిపోతుంది. మనకి ఇక్కడ కావాల్సిన OpenShift అంటే ఏంటో అవగాహన పెంచుకోవటం కాదు కదా, వాడటం కదా. అది కావాలంటే ఫస్ట్ Kubernetes ని వాడటం తెలియాలి. రైట్. సో ఐఎమ్ క్లియర్ ఆన్ దిస్. కార్ నేర్చుకునే వాళ్ళు ఎప్పుడన్నా, బైక్ అలవాటైన వాళ్ళు కార్ నేర్చుకుంటే పెద్దగా ఇబ్బంది ఉండదు కదా, అవునా కదా? ఓకే, సైకిల్ నుండి కార్ వెళ్తే, మీరు సైకిలే నేర్చుకున్నారు, ఆ తర్వాత బైక్ గట్ట ఏమి తోలలేదు, డైరెక్ట్ గా కార్ నేర్చుకోవడానికి వెళ్ళారు. అప్పుడు ఒక విషయం మిమ్మల్ని బాగా ఇబ్బంది పెట్టుద్ది, గేర్లు. అవునా? అదే దారిలో ఏ చేతక్కో ఏదో ఒక గేర్ బండి నడిపున్నా కార్ ఈజీగా ఉంటుంది. అవునా? అలాగే ఓపెన్ షిఫ్ట్ రావాలంటే ఈ గేర్లన్నీ కుబర్నెటాస్ లో ఉన్నాయి, రైట్? సో దిస్ ఇస్ లైక్ ఎ బైక్ బిఫోర్ యూఆర్ ప్రాక్టీసింగ్ ఎ కార్. ఓకే, సో ప్లీజ్ ఎన్షూర్ దట్ you come with an understanding of it. Okay, so I am not here to cover syllabus. If that was the case, we don't need 90 days. If that was the case, I don't need 90 days. For example, while I was drawing an image of everything, I could have written a simple YAML file. Okay, I could have said that kubectl apply -f చూసారుగా అయిపోయింది అని చెప్పి ఈ పాటి కుబర్నెటాస్ కూడా అయిపోతుంది. నేను చేయలా. The reason for that is because I want you guys to understand all of this. Okay, clear? So schedule, please don't give me suggestions. I'll work out on schedule, right? So I am working on my schedule to ensure that I am teaching everything in Kubernetes. Whether you are learning everything in Kubernetes is your problem. Try to work on that, right? Okay. And inkoti, especially for the people who are looking for jobs outside of India, there are many contract positions open on Kubernetes. Okay. So we have some of our students who join from Canada, from US. Their major focus is Kubernetes, right? So Jenkins, Kubernetes, and basically any scripting language, right? These three are a minimal combination to get a job in abroad, let it be US or Canada or UK. Yeah, especially for the people who are trying abroad, this is the basic moral of the story, right? At least as of now, from the last 6 months that has been trend. Okay, so you can look into your job portals and you will find out the same thing, because there we'll have short-term contractual position, right? 6 months or one year of hire and all of that stuff, right? For that. Okay. Is OpenShift only for Red Hat? Okay, we'll first worry about Kubernetes. I'll worry about OpenShift over next week. Okay, right? OpenShift is not just for Red Hat. Okay, it was made by Red Hat. Yes. Okay. Right. Yes.
Upgraded the application.
Yeah.
The application made some changes.
Mm.
So once we revert back,
Mm.
what is going to happen?
Then you should have two different volumes. New version with a new volume and older version with a older volume. If you revert back, you are going to the older volume. If you are going to the newer version, you are not using the older volume, you are going to the newer volume, where you copy the data from your older volume. That's how you are supposed to do it. Yeah. So, see, one point is, you have said that you are working on MySQL, right? In MySQL, where is the whole of the data stored? I mean, internally. Internally, when I store it in MySQL, where is it getting stored on my Linux system?
Right.
File system, yes. So if my schema changes, I'll have a new set of file system, right? Yes. Yeah. So if I am able to run, if you as a DBA admin, basically tell that, okay, I have this stuff, can you please import it and then create a new database out of it? Can you do it? నా దగ్గర ఆల్రెడీ ఒక ఫైల్ సిస్టమ్ ఉంది, సమ్ బ్యాకప్ ఉంది. From that backup, can you take the data and then recreate the database with new schema changes? Yes or no? That is what you should be doing. That is what you should be doing, right? Okay. So when you revert back, you'll not have a problem, because you're not no longer using the older volume. You have to use a newer volume. DB schema changes is not reusing the older volume. That is ETL kind of operation. That is ETL kind of an operation, right? And generally, okay, for the applications, whenever we make any changes, we'll ensure that we are not making changes to the existing schema, we add new tables to it. That's the best practice, always. Yeah, okay. ప్రపంచం ఆ దరిద్రాన్ని భరించుకోలేక MongoDB వెళ్ళిపోతుంది. ఈ MySQL వీటి నుండి ఎందుకు వెళ్ళిపోతున్నారంటే ఎగ్జాక్ట్లీ దిస్ ఇస్ ద ప్రాబ్లం, రైట్? Why I have to worry too much about structure of the application? I want something which is faster and retrieve the data. That's the whole point. Okay. Fine then. So any other questions in the classroom? Right. రేపు పొద్దున 7:00 అన్ని అస్త్రాలు సిద్ధం చేసుకురండి, లేదా వెనక్కి వెళ్ళి పడుకోవచ్చు. రైట్. ఓకే దెన్, థ్యాంక్స్.